All right, hey everyone. Do you recognize me? Probably shouldn't. This is the first time I've done a video on this channel. I feel like this setup is a lot nicer, a lot cleaner, more kempt, so I'm going to use this. Today I am going to evaluate this and this, these two integrals. And they should look pretty. Actually, yeah, they're both non-elementary. So, just to get started, let's evaluate this one first. It's a lot simpler. Just do a u sub. U equals sine theta, and then du equals cosine of theta, d theta, and you see we already have this right here in the integral, so they're going to cancel out, or they're going to get sucked up into the du. So then we get, okay, so change our limits, we get sine of pi over 2, that's 1, get the integral from 1, okay, sine is 0, that's 0, so then we get the integral from 0 to 1, e to the minus u squared du. This is going to be equal to, have you ever heard of this function called the error function? I'm going to post a link to Blackpin Redpin's video. So to solve this, we're going to use this new function called the error function. This defines this following definition right here, from 0 to x. Square root of pi over 2 times the error function of x is equal to the integral from 0 to x e to the minus t squared dt. Alright? Yeah, that checks out. So we're going to use this on this, and then we get square root of pi over 2. Our x is going to be 1. We have square root of pi divided by 2, error function at 1. Alright, we're back. So this is, you can't use some normal u substitution for this problem right here. So because the du doesn't cancel out with the d theta. So or the sine theta doesn't cancel out with the du. So we're going to have to think of something else. How could we turn this sine into a cosine? Use the fundamental theorem that you are all taught on your first day in trig. I haven't taken trig yet, but I think this is what you were taught. Sine theta plus sine squared theta plus cosine squared theta equals 1. Subtract sine squared from both sides of the equation, and you get cosine squared theta equals 1 minus sine squared theta. Alright, you should all know this. I shouldn't even write this out, it's so basic. So we just subtract 1 from both sides of the equation, and we get cosine of theta, cosine squared of theta, minus 1 equals minus sine squared of theta. Here, just put this. Substitution property. Put this inside of this. So then, if we were to do that, we're going to get to the integral from 0 to pi over 2, e to the cosine squared of theta minus 1 times sine theta d theta. Factor out the minus 1. It's going to give us 1 over e times the integral from 0 to pi over... Why am I writing it so goddamn small? And so this is going to give us 1 over e times the integral from 0 to pi over 2, e to the cosine squared of theta times sine of theta, d theta. Now we can use the u sub because we have cosine, sine. They're best friends in integration. We get u equals cosine theta. Du equals minus sine theta, d theta. And so then just multiply both sides by -1. Then this, yep, it's right here. So that's just going to turn into our minus du. And so now, just got to analyze our new limits. It's going to equal 1 over e, is the integral from 0, cosine 0, 1, cosine pi over 2, 0, minus sine, swap the limits, you get from 0 to 1, you get e to the u squared, and then du. And now, gonna have to apply another non-elementary function. Square root of pi over 2 times this new function, phi of x, equals the integral from 0 to x, e to the t squared, dt. Apply that to this, and then we get, this is equal to square root of pi divided by 2e. Our x is going to be 1, so our x is going to be 1, so it's going to be the phi evaluated at 1. There you have it. That's both of these somewhat challenging integrals solved. Hope you enjoyed. Click the subscribe button if you feel like it's necessary. I hope you all have a fantastic and fruitful day.